Focus on me. Okay, there we go. Welcome in, everybody. It is great to have you here. Now, normally I would jump in straight to woodworking. I've got to shoot an intro for this. I got to set the stage for this video. It's a really cool, unique video. I've partnered up with Anker on this video. They're providing a home panel for my house, which provides backup power if the grid goes out. And that backup power is provided by their Anker Solix F3800 portable power station. One thing that really kicked this off for me was several years back. We had the snowpocalypse in Texas, and everything shut down. It was actually really not a good situation. Power failures across the state. We lost power here. It was a mess. So I've wanted to do something to back up the power in the house for a while. So this is an awesome opportunity working with Anker. The cool thing about this is just kind of the first step. I can add power stations to my system. I can add the solar and eventually get it to where it really can fully back up my house indefinitely. So unfortunately, the power panel to my house, my main panel, is in our little desk nook, and it's a total mess. It's been a mess for a long time. My wife and I have been wanting to fix it up and make it a usable space. And so this is a great excuse in this video because we've got to install all these electrical components around my electrical panel, and I want to make it look nice because it's in the middle of my house. So I've got some fairly complicated woodworking to do to build a really cool floating desk out of some spalted Texas pecan, and then a panel, kind of a faux panel to cover all of the electrical components. And we're going to leave that panel to where we can see the Anker panel, which I think looks pretty cool. So it's a very unique video in that we're doing some electrical work and some really cool woodworking. Now, real quick, I want to give a quick overview of the Anker system. This is a portable power station that provides 6,000 watts. You can recharge this thing with up to 2,000 watts of solar. So eventually what I could do is put solar on my roof, run a line down, and almost indefinitely back up the house if power goes out. Now, when I say back up the house, you select 12 circuits out of your main panel to be your backup. Those are the circuits that the power station will actually back up. Okay, so what we're going to do is we're going to jump in right now. We're going to do an install, real quick install of the panel, and then we're going to do the woodworking. We got to make this cool desk, and then we're going to have an overview of how the system works hooked up to my home. And then I'm going to bring it up to the shop, and we're going to run some power tools on it and really put it through the test. And then I'm going to take it out to the Argosy, hook it up to the RV, and see how it powers my RV. So all of that is laid out down low in the timeline in chapters. So that way, if you want to navigate to certain sections, that can easily be done. Now, let's jump in and get started on the install. Okay, so like I said, I'm not an electrician, so I'm going to do the best I can to explain this process. So what we got here is my main panel all opened up. It's the panel that feeds my house. Right now, Nathan is hanging the Anker home panel on French cleats. This is basically a transfer switch, so anytime it detects that a power is lost from the grid to the main panel, it automatically transfers on power and sends it from the battery to this sub panel here that we're hooking up. So you've got 12 circuits you can choose from your main panel. That's what all those wires are hanging through there. Nathan's already run those and is just pulling them through to the sub panel down there. You also got a pass-through, so you got power coming from the main panel through the sub panel, and then through some conduit that he's going to run up to the Anker panel, and then that power will drop back down into the sub panel. So he's running conduit here, and then he's just working through the circuits, stripping wire. This is about a day and a half's worth of work compressed into about a couple minutes. Like I said, there's a lot of good resources online that really in-depth explain how this works. You know, if you're installing this in your house, first I'd recommend getting an electrician. Second, I'd recommend watching a few of these videos. He's going to set up here and do the initial kind of hookup right now.
240 hot to hot, phase 1 to neutral 120, phase 1 to ground 120, and then we check phase 2 to ground 120, 120. Let's see if it's passing through. So this is our load side. Okay, so it's not passing through right now, so I don't know if we have to turn it on. Probably.
Oh, like where it says on off, yeah.
I can see it lit up. Okay. All right.
Something clicked.
Yep. Yep. There she is.
Okay, so here's a shot of all the finished work he did. Awesome. Really appreciate his skills. It looks great. I can appreciate another tradesman's work, and this is all clean and looks real nice. So I'm glad I had him to be a part of it and help out. Now we've got to take his really nice work and do the equivalent with the woodworking and make these panels hide away in a nice presentable way. So big thanks to Nathan. I'll link his stuff down in the description. Let's get to some woodworking. First thing we got to do is pull some slabs out of my private stash here. So I've got some pecan that a client gave to me, some spalted pecan, so we're going to use that for the desktop. The hard part obviously is getting it all out of the storage container. You can see I got some nice cherry in there, my sycamore still in there. There's a lot of lumber in there, a lot of mesquite, some oak, more pecan. Get an idea there of how, well, you don't get a great idea, but you kind of get an idea of what that's going to look like. Sorry for the bucket of stickers there I knocked over. So I'm going to break this down outside the shop. I could do it on my big bandsaw in the shop, but it's such a big, heavy piece. It's just easier to set up some sawhorses and bring the track saw to it. So basically we're going to cross cut it, rip off the live edge. I've got to make two pieces. I got to glue up two pieces. One is about 86 inches long by 27 wide. That's the main floating desktop. And then the second is actually where I rotate the grain 90 and go the other direction, almost like a breadboard in, and make a little end cap. And that's kind of the area where the electrical components go. One of the reasons I did that is because I'm actually going to radius out that side part where the electric components are. So I turn the grain. If I didn't, I would have a real fragile part there because I'm cutting cross grain. So I just rotated that end piece and kind of made a little cap on the end. I'm not going to go in depth on the joinery here or the milling of parts. Basically, we're going to face joint everything on my joiner, and then I'll throw it in on the planer, thickness it. Everything went down to about 1.5 inches final. So it gets thickness here. I go back to the joiner, I joint the edges, put it in the clamps, glue it up, and then run it through a wide belt. That whole process does not get shown, but that's how it goes. I've done a lot of milling on this channel, so we're just going to move on past that for this video. Now we're on the CNC. I'm just making a jig here for that piece I was talking about that's on the side by the electrical panels. It's got the radius. You can see it here in the rendering. The left is that curved piece where the grain's rotated, and then the right is the long piece that's the desk surface. So we've got the jig made. I'm going to trace a line onto it, and then I'm going to take the waste off. I get to use my really awesome almost 100-year-old Oliver bandsaw. Two of these now. I have a little one and a big one, and the little one's just as awesome. It's the thing I love about this saw is that the top is big and beefy, so I can take a heavy piece like this and go up and cut a radius without having to change the blade on the big saw, which is quite the task. So cut out that waste, leaving about a 1/16, maybe a little less, and then I can come in with a flush trimming bit on my router, use my jig, and just trim that up. Go about halfway down on this 1.5 inch thick material, and then I'll pull the jig off, and then we can ride the groove I just made and cut that bottom part. All right, so making a cut, you're gonna get a magical cut here where I'm changing bits because that bit actually wasn't quite long enough. So I'm going to be swapping out bits here. This is a cool bit. It's got bearings on top and bottom, and it's a beefy one, and it has a long cut length to it. Now, with that shaped out, I'm going to take the jig I just used, take it into the house. Nathan's still working on his stuff here. You can see the panels are open, but I'm just marking out where his conduit is so I can make a nice clean notch around not only my top, but the two boxes that are going to encase these electrical panels. So once I marked that, I went to Fusion, designed up a little cutout, and put this back on the CNC and cut it out. Now I'm cutting the top of the bottom box. I didn't show how I built this one, but we are going to show how we build the top one. And I'm doing this in one pass. It's quite the aggressive cut, so holding on tight and just knocking it out. That's poplar, three-quarters of an inch thick poplar. So, you know, it's a soft wood. It's not overly aggressive cut. Now, I'm not going to do that on the top. We're doing the same cutout here on this top piece of pecan. I went ahead and roughed it out and left a little bit there and just shaved that off. And even that little bit, that bit's screaming a little bit because that's just hard material. Okay, now this is our bottom box. You can see the face there facing out is a nice piece of pecan. I've got a cutout in my trim down there. I've already cut the trim out, so it's just gonna slide right in that corner. And then the top is gonna go right over on top of that. And then that cutout's gonna let that conduit get through. I'm gonna put cleats up along the back wall. Actually, my dad did that for me. I'm not gonna show it, but just so you know, there's cleats back there. Now that I've got this installed though, I can get measurements for my top box and we can go build that. So I milled all the parts. Basically that front face is the pecan, and then I have a rabbet on it set back about 1 inch, and then the poplar is all fitting in around that. And I'm just dominoing it together. Make it simple and easy, glue it up. I could put it together with screws, but I didn't really want screws in the face of my box that you're gonna see. So my dad is looking for a tape measure, or no, he's looking for the drill. And so now here I am helping him find the drill. There's always something to find. I gotta get the shop. The shop is in dire need of organization. I've been so busy. It's time to knock that out. So we found the drill. I'm gonna glue up now, and then we're gonna put this in the clamps and let it sit for a few hours. You can kind of see that on the bench there, that rabbet. So the pecan steps back that inch, and then the poplar is not as wide as a piece. So the panel will actually drop in, and the edge of the panel will be covered by the pecan on the front. You can kind of see it in this shot too. If you look to the right side of that box, you can see that the pecan front face is wider than the poplar. All right, so we got to make that same cutout. My camera is magically, for some reason, falling down. It's going to stop here though and barely leave enough to watch. Same thing we did on the bottom box, we're going to do on the top box. We're going to make that cutout because the bottom of this box has to go around that conduit. Getting aggressive again, doing it in one shot. This is a great little bit. It's got top and bottom bearings, insert tooling, so I can swap out the tooling on it. It does have a little bit of vibration in it, so you got to slow down the speed on your router, but other than that, it works great. So we're back in the house. I'm going to set the bottom box. Everything's been finished. I shot lacquer on it. You can see behind me my dad's installed the wall cleats. Those are just a place for those tops to rest on. Give it the old test there. Just toe nailed a few screws in, nothing fancy. You're not going to see them. Check it for level. And then I'm going to put these little figure 8 tabs in for the tops. So basically you drill with a Forstner bit a little hole that's a little relief, and these will drop down in, screw to the box, and I'm going to put them on those back cleats. And this is how the tops will get attached to the box here, and then the cleats. Basically the idea is kind of have a floating top. It's not really heavily supported, it just kind of spans that wall. Now you can see the beautiful top. That spalted pecan looks amazing. I've got a water-based lacquer on it. Slide it in, and then we're going to screw it down, and it's secured and in place. Now the top, same deal. It's all finished with a water-based lacquer, and it should slide in here really nice. I had to notch it on the right side to get around that home power panel, the cleats. Can't actually see that, but there was one more notch I had to do in it. Okay, so it's in place. Now, the cool thing we're going to do here is that front panel is going to actually allow the Anker smart home panel to pop through. So you can see it because there's lights on there, there's displays. You want to see how it's functioning. So I made another jig on the CNC that's basically the opening of that panel. I'm using it to cut out an opening in the main big panel. Very simple stuff. This is not complicated. Anyone with a router can do it. Making the jig can be a little tricky without a CNC, but it's doable 100%. Good fit there. Now I kind of hammered that a little bit because that conduit is not allowing that 3/4 plywood to drop all the way in. So we got to solve that. A little bit of hand tool work. We're gonna carve it out with this gouge. Interesting fact: fourth video I ever made on YouTube years ago when YouTube really liked me. I got 25 million views over the lifetime of this video carving a spoon with this little gouge. I don't know, I like to mention that. This gouge is, a lot of people have seen it. Now, I don't have quite the popularity I used to have, but I still use this gouge all the time. I love this gouge. Carving in plywood, no one does it. There's a reason why, because the grain's going in multiple directions. So it's, you know, this, you're never gonna see it. It's behind the panel, so it's hidden away. All right, the top goes in. Now this is kind of a mistake I made. I'm gonna let our audio play out here. This is not gonna work. There's a bulge in the wall right here. So this whole slide-in thing is just kind of, what it should have been is a half lap. Should have done a half lap. So if I get past this bulge, I don't think I'm getting.
If it's not possible to angle it down like this without chipping something off.
We could try. Okay, so my dad's idea works. He's smarter than I realize always. Just tilted it up, got it to slide in that groove, and then it dropped right into place. Beautiful. That's how you do it. Get a nice hit. All right, so. Okay, back in the shop, I had my dad help me, or actually I had my dad put cork tiles on these plywood panels after we got them all fitted. Basically, we're using polyurethane glue as a Gorilla Glue. I didn't want to use a water-based glue here. You can use Titebond. Just because putting water on these panels and adding that moisture to the plywood and only doing it on one side could cause it to bow really bad. So we're using a non-water-based glue, spreading that on there, and then just a little bitty pin nailer and shooting a ton of nails into it. That little pin nailer, you can never find the nails because there's no head on it. Do both of these panels, it went fairly quick. And then once those are all secured, we did a little bit of clamping on the outside edges just to make sure everything squeezed down and set well. Once that glue was secured, I could flip it over and just take my flush trimming bit like we've been doing and just trim off the excess hanging over the plywood. Making sure right there that I didn't have any wet glue. I thought I did this pretty quick. I only let that glue sit for about an hour and a half, and then I came back and routed it. So I just wanted to make sure that glue was fully dry. And now that we got all this done, we're gonna go in and test out this battery system and see how it works. Okay, so we got everything hooked up. I wanna do kind of an overview of how this system works. First thing is the panel, the cork looks really nice. So this is a spot where my wife can pin up some stuff, put calendar things, notes, pictures, things like that. So I think that's cool. And I just carried the cork down to the bottom just because it looks, I think it made sense. It looks good. So there's no use for it really down there. You could pin something down here. And then the Anker Solix 3800 is just gonna stay right there. The cutout is right in a position where we can just slide it right up against the wall, and it's plugged into the home power panels. So let's pop this wall off. I'm gonna kind of give you an overview of everything. I wanted to make this fairly easy to get off in case, you know, an emergency we needed to get to the circuits. So they're just on there with magnets. So I can just pop that panel right off and it shows us everything. Okay, so let's talk about the home panel. This is really the kind of meat of the system that allows that battery to recirculate into my home and power my home. So we've got the main circuit. You saw this all got installed. We've pulled 12 of these circuits off down into that sub panel below, and then that's feeding, there's a pass through of power going into the Solix here, and then an output of power going to that sub panel. So that output of power is powering those 12 circuits in the sub panel. Now, if you're creative in how you design this, you could really set it up to power most of your house. Mine, I've basically set it up to power various lights, plugs, the fridge, the septic pump. That's the basic overview of how the power is working. You've got some LED lights on here, so you got your on off. This is showing grid power. This is showing power station 1 is hooked up. Power station 2 is not hooked up, so you can hook up 2 power stations to this, and then there's a backup load that has power. So this thing is capable of powering 6,000 to 12,000 watts. It's dual voltage, 240 and 120 volts. So that's one of the great things about it, is I can run my well pumps, which are 240 volt pumps. I just got to figure out how to get that connected into the system. You could run, if you wanted to, your AC, your dryer. I mean, you could run all your higher voltage appliances. But for my purposes, I only have one battery hooked up. So those loads would be a little bit heavy for one battery. But if you had multiple batteries, you could design this system and really build it out with multiple batteries and solar and power everything in your home if you wanted to. Great thing about this cool thing is it's got a little antenna. It's got connectivity, so there's an app. I can go in here and I get real-time data on what is happening with my home. You have control over how much power the battery sends into your home. If you have it set up to where you have solar and you can replenish that power, you can feed in and save money on energy by allowing the battery, let's say you can set this. So let's say I set 80% of the battery to be used for home use. Well, that 80% will flow into my house until there's 20% left on the battery, and then it's going to hold there for an outage. So if power goes out, you got 20% of the battery there. Now, I'm not using it that way. I'm not trying to save money. I want the full 100% of battery for the power outage. So my setting is 1% power for home and 99% reserved for outages. So if we get a power outage, I've got 99% of that battery to run the 12 circuits hooked up on the sub panel. Okay, so the Anker Solix. This is 6,000 watts supported, dual voltage, 240, 120 volt, which is great because I have plugs over here. I can actually plug the Argosy in that. This can go up to 12,000 volts, or watts, I'm sorry. And that's supported also by the Anker Home Smart Panel if you connect two together. So if you put two of these together, you get 12,000 watts. You've got your 240 volt, 25 amp plug here for an RV. Coming up front, you've got some USB-C plugs. You got a cool display that gives you all the data on this. Currently, it's charged up to 99%. Nothing is coming in, nothing is going out, but it'll tell you what the output and input it is. And then spin her around. You've got your connection to connect your other power station to it. So you can add to this. You've got solar input here. So the recharge on this is actually pretty impressive. There's multiple ways to recharge it. You can recharge it to 80% in under an hour hooked up to the wall. You can put up to 2,400 watts of solar on this as well, and that'll recharge it within 1.8 hours. So if you get this thing maxed out and all the solar on it, you can recharge this sucker pretty quick. Okay, so let's simulate off-grid power real quick. I'm not going to cut off the whole main power to the house. Basically, we're just going to shut off power to the sub panel down here, which will automatically, this will transfer power back to it using the battery. So I'm going to pop that off. See how quick that is? That's a split second. We've lost the grid power right here. The light's off on that. Power station is still plugged in. We've got a backup load going. So a quick look at the stats where we're at. We've got 96 power on the battery. It wasn't fully charged when I clicked it off. It's using 606 watts to power that house right now, the sub panel. That's going to last, the battery's going to last about 5 hours on that 600 watts. Now I could probably get that 600 watts down if I turn some things off low on our power consumption. So that kind of gives you an idea of what it can do. So if we had 2 of these batteries, we would be at 10 hours of backup power. And then if we had, the 2,400, even less of solar hooked up to it, we would be running indefinitely because we can cancel out those 600 watts using our solar. So all in all, I mean, that buys me 6 hours of time if the power goes out. Rarely here do we get long-term power outages. And in any case, if you do get a long-term power outage, you need solar to obviously charge things. So that would be the next step for me, is to add some solar panels to this. If I got enough solar on it, I could run this thing indefinitely. But for us, even when the snowpocalypse happened, we were getting intermittent power outages. So they would shut our power off for a couple hours, kick it back on for an hour, and this would go on for, that went on for about a week. And so while they shut it off, this thing would cover everything and then it would come back on. So, I mean, it's cool. It's good. It's a good backup. This could, and I can expand it easily. That's what's great about this system. So I'm pumped. I'm pumped to have it. I'm thankful for Anker. We've got everything set up and it works flawless. It works beautifully, and it looks nice and clean in this space. Okay, so we're gonna cut power back on, and then this panel now has power going to it, so the grid's powered up. We'll go down to our battery, get the display, and it's going to take a little bit of time. There's a bit of a lag because sometimes power cuts in and out, so it's waiting, giving a little bit of time before it kicks on and takes the battery offline. There it goes. So you hear the click. Battery is now offline. We're running completely off the grid. And then what we're going to do now is start inputting power into the battery to charge it. So now it's inputting almost 2,000 watts from the house. And it's going to take 0.1 hours to get this thing back up and charged. Okay, we're all hooked up. It's slightly ridiculous, but basically what I'm doing here is just kind of simulating like a crew of guys working. So we've got our batteries charging up here. I've got mics for my camera charging. I've got a compressor, because there's always a compressor on a job site. Those suck power. Got a guy over here using a skill saw without a blade doing something. And then we've got one guy over here sanding something. He's got the dust extractor hooked up. That thing draws with a lot of power. And then we'll have a guy back here. I'm going to be all these guys. Cutting on the miter saw. This thing will draw a lot of power as well. So we're going to have all these machines going at once. We're just going to see what happens. I'm going to go make a cut on the miter saw. Alright, no problem. Okay, so we're inside the RV. I've got the Anker Solix 3800 plugged in, and it's basically powering this bad boy right now. Now, I am still in absorption mode on the batteries for the camper, which means that the inverter, the camper inverter, is drawing some power from that battery to continue finishing the charging of the camper batteries. So basically we're exchanging power from battery to battery, which is about a 800 watt pull on it right now. So I'm just gonna flip this camera around. Battery's at 100%. So at the current use, without the AC, we could have 5 hours of power on this camper. But let's see what this thing's got, and we're gonna turn on. It's hot here in Texas, so I got my AC up there. We're gonna click it on. All right, so the AC just really kicked in. Now we're going to see that wattage go up. We're at 1300. So the output right now is around 1300. Okay, so it's climbed up to around 2200 watts of power. Subtract, I don't know, another 1,000 of that because it's putting it in the batteries. It's really using 1200. So obviously with the AC on, it's going to use a lot of power, but it's impressive that the Solix can keep up with that. So obviously that thing has no issue running this RV. Anything I threw at it, the water heater was along with it. Didn't have any issue with that. The AC obviously didn't have any issue. So if I'm boondocking, I could take this thing with me. It'd probably be best to be doing it in a time of the year where you don't need the AC, because without solar, you're probably going to drain it. You don't have a lot of AC time. Now I do have solar on the roof. I have 800 watts, so I could technically run that power back into the Solix and recharge it. So that'll wrap it up for this video. Big thanks to Anker for sending over the power station and the home power panel. Really appreciate them. I'm excited to have it in my home as a backup. If you guys need any more information on that, everything is linked in the description, so you can go down and check it out. I just want to say thanks to everyone for tuning in. Appreciate you guys. Leave a comment, let me know what you think, and we'll see you next time.